whiteboard over here, is that when we're talking about parabolas now, we've all worked with these, but you've worked with them in terms of, y equals 2x squared, or you walk through and dealt with the curves of factoring with your ax squared plus bx plus c, where you take half of b over 2a, find your vertex, and do all that other mumbo jumbo. You've done that process before. What's going to be a little bit different now as we throw the algebra 2 twist into it is that we're going to start talking about a couple of different parts of the parabola. Two parts that we're going to start looking at here, one of them is called a focus, and the other one is called the directrix. All right, so not only are we worrying about where the vertices are going to lie, we're going to find what's called the focus and the directrix. Parabolas always open towards the focus. It means they're looking at something. It's pretty easy to think about. You're focusing where you're looking. The parabola will always open in the direction of the focus. The directrix, on the other hand, is a, let's see how you want to put it in a real nice, easy way, is always equidistant as well. They have the same distance between the vertex to the focus as there is from vertex to the directrix. And the directrix is always perpendicular to whatever axis of symmetry the parabola may have. You did stuff like this in the past where we had y equals 2x squared minus 4x plus 10. I don't know. Just making something up. Where you guys were able to find the axis of symmetry. When you did that, you found the axis of symmetry by using opposite of b over 2a. The axis of symmetry for a regular parabola was always a vertical line. Do you remember that? So it was always an x equals. Well, what's going to change up now is that our parabolas are not only going to be opening up like a cup or down like a frown. They're going to turn left and right.
Do you have any rhymes for
I don't. But I'll leave it up to you to figure it out. No. Now, what's going to happen here is if we have an x squared term, it's always up or down. If we have a y squared term, it's going left and right. That's the main difference now. Okay? So what we're looking at is a different form of the equation, a different way that these things are going to look. Again, this directrix, and you don't have to worry about right now, it's always going to be perpendicular wherever the axis of symmetry is. So if your axis of symmetry is an x equals a number for vertical, your directrix is always going to be a y equals a number. If your axis of symmetry is a y equals a number because it's a y squared parabola opening left or it's opening to the right, that means your directrix has an x value for an x equals for a line. What you're going to find in this chapter of conics, parabolas, circles, ellipses, and hyperbolas, it's all a matter of some very standard formulas. And we're going to work through them. It's a lot of substitution, solve for a specific value, and plot. Just like when you first learn how to graph trinomials, where you find your axis of symmetry, you substitute in, you got your vertex, you plot a couple of symmetrical twins. It's basically the same idea, but we're going to talk about it in different terms. We're going to look at them in terms of these two styles of equations. Okay. Today, these first four sections, parabolas, circles, ellipses, and hyperbolas, everything is going to have, it's going to be centered around the vertex, around the origin. There is going to be no horizontal or vertical shift to anything until we get to section 10.6. When we get to 10.6, everything starts moving around. All right, everything will move around at 10.6. So these first couple of sections is all going to be nothing more than, here's what the shape is going to look like, how do we plot it, how do we write the equation, how do we make these things mirror themselves around, and then from there, we just start moving them left, right, up, and down. So we have two basic equations. We have an x squared parabola, which we all know as a up like a cup or a down like a frown. The equation is now going to look like this. X squared equals 4 times p times y. This value of p allows us to figure out both the focus and the directrix. excuse me, when we have a y squared parabola, that just means it's opening left or right. Again, if the p-value is, well, I should go back to this one. We knew that a parabola opened downward if the a value was negative, down like a frown. In this case, now we're talking about the p-value. It's a little bit different. Okay? So if the p-value is less than 0, it's opening downward. P is greater than 0, it opens up. Same thing if it's going left and right. If the p-value is negative, it's pointing towards, it's opening left, it's opening towards all the negative values. And if the p-value is greater than 0, it's opening to the right. Just using your simple ideas of the number line here. Let me write these parts in here. Your focus is always going to lie. If it's an x squared value, your focus is always going to be 0, comma p. The directrix, the opposite of p. One thing I want you to notice, if it's an x squared value, the p falls into the y. Okay? It's a little opposite. It's counterintuitive what you want to do. When it's a y squared, it falls into the x's. Oops. I was trying to use my hand.
What is focus?
P is going to be the point at which that is equidistant from the center of the parabola, the vertex. Yeah, and it's a very easy way to find it, and you'll see it here in a second. All right. These are very, very easy to work with. Trust me. No, don't lose faith. Not yet. I want to find out some stuff. Grab 2 sheets as this is going around. I hole punch it so you can have one with your notes and one with some homework later. And we'll walk through this one of these. We'll do it this way. All right.
Is the 4 like integrated into the negative 1 and 6?
Yes.
So
Yeah.
should have been more negative 1 or 4.
So let's take a look at this here. Now, what's going to happen, whether or not it's an x squared parabola or a y squared parabola, we're always going to do the following same exact steps. Is this an x squared or a y squared parabola? Y squared. Is this open? So this means it has to go left or right. Do you know right now what direction it's going to go? Yes. It's going to open to the left. I know this has to open left, so I'm just going to put a little hint to myself. It's got to go like this.
Wait, how do you know that?
Look at see how it's negative? So it just means it's opening to the left. It's y squared, so it's a left or a right one. Okay, so I know that. I don't know what my p value is or anything right now. So what I want to do is I want to fall back into setting up to figure out what 4p, yeah.
I thought the geometry taught that you have p-value.
We do, but since it's already negative, we can go another route here.
Oh.
Okay? Since we already know that it's negative, we know that. We're still going to figure out what the p-value is, but we can set it up this way. All right? So when I set this up, I want to get y squared by itself. Yeah. Everybody okay on that?
Yeah.
Now, for some odd reason, I think I wrote that generic one down wrong. I think I flipped my X's and Y's. I did. Nuts. I'm sorry. I thought something looked weird when I was looking at that. This is x squared equals 4p y. I wrote it backwards. The squared term is supposed to be on the outside. I'm sorry.
It's
I know. I do apologize. Real fast, guys, let me put the light on here. When I wrote out the generic equation, I accidentally had the x squared into the part of both of these. It's supposed to be on the outside. I don't know why I did that. Because it's Monday, it was a 2.5-day weekend, and I have to talk about iconic in
A year.
10.5 months. So, yeah, about a year. So you'll have to forgive me. So let's change that real fast. Make sure you have x squared equals 4py, y squared equals 4px. I do apologize, I wrote it down incorrectly, but yet when we looked at it here, it was normal. I didn't catch it. You should have noticed. You all failed for today.
You were blocking the board.
You can point a finger, but the three coming back.
He's good. He's very good. You're 5. I'll give you that one. That's really good. So again, I do apologize. I screwed that up, which means I'll never screw that up for the other classes, so you guys are going to get it.
Well, I mean, the geometry class before I saw that mistake too, but I didn't catch it.
That's true. Now, notice here, we've got y squared by itself. What happens here to figure out what this p-value is,
You divided by
what you do is you go back to the generic equation. Does everybody agree that the -6 is being related to by the 4p? Since it's out in front of the x value here, what you do in order to solve for the p value is you take them and you set them equal to each other. It's Monday, 2.5-day weekend. So your p value is -3/2. Okay? What I'm doing here is I'm just figuring out what the p value is now, because I know that my my vertex for the parabola itself is going to go through the origin. The p value is going to allow me to find the ordered pair for the focus. What is it looking at? And then the opposite of the p value gives me my directrix. Okay. Excuse me, what was that?
So the focus is -1.5.
Yeah, because now we know that the focus here will be at 0 and -1.5. The focus will then be at -1/2 or 1.5 or -3/2, and your directrix would be at +3/2. Oops, one too far. So we know that the vertex is at the origin. I won't use red. Because everything that we do today, over the course of the next few days, the vertex will be centered around the origin. Eventually, you will see the H's and the K's. I know that it's looking towards the left, and the focus is at -3.5. So the focus is at that ordered pair. And then the directrix. The directrix then, well, if it's a parabola that's going left and right, that means that the axis of symmetry is a horizontal line. Do you agree? So the directrix becomes a vertical line. And the vertical line is x equals 3/2. It's always the opposite of the sign of whatever the p value is. And there's that. Now the last thing we have to do is figure out the curve. Well, it's got to open left, right? Could we just pick a really easy point, maybe substitute in some stuff? Because in our calculators we don't have a y squared button, do we? I don't. But can I do this? and look at a table? Could I do, but here's the problem though, we've got that negative 6x. So it becomes nasty. Or does it? Because it knows it's going left here. So take a look, see what you can get.
Errors.
You getting errors?
No. Negative 6 equals 6. Why?
Because what's going to happen here, guys, is we're going to be able to use our calculators to get some table stuff for a few of these. Because all we really need is just a couple sets of points. If you pick any negative value for x, won't that negative times a negative drop itself out? Yes, sir. Okay. So if you start looking at your table, won't it work? No. Oh, thank you for not letting that hit Julie on the head. What was our equation here? Was let's just do a square root. What was it? Negative 6x. If you look at just the graph, I did type in the negative value of it, I got that top curve. Now, if you're getting a bunch of errors on your table,
No, that was in the positive. Wait, what did you just type in?
I just typed in the square root of negative 6x.
Okay.
Because now if I go to my table, at 0, it's 0. If it's positive, it's not going to work. But if at negative 1, I know it's almost 2.5. At negative 2, it's almost 3.5. There you go. At negative 6, it's 6. Are you getting this okay, Sean? When you're in your y equals part, just type in the square root of negative 6x. Did you use the minus button? There you go. Yeah, that's usually what happens. If you're not getting something, you probably you probably got the minus button by mistake. And you're right. This is you're going to have all these symmetric twins. So if we found that we've got one nice point at negative 6, it was positive 6. That means, isn't there another symmetric twin down here as well? All right, so I know basically how wide it's going. That's really what you want to look to be able to do, guys. Try to find at least one point to get you how wide it's opening or narrow it's opening. Okay? One of the things that you'll notice over time as you're working with these, the closer the focus is to the vertex, the wider things get. If it's further away, it's narrowing its focus. Sorry, Dad played on words there. Yes, sir.
I thought it was
What's that?
I thought it was focus.
Go through the focus?
Yeah.
No, it's going to the vertex is at the origin. It's looking at the focus.
What's the point of the focus? I was just with
What happens here is as you get into more of, what is it? Not photography. If you're looking at curvature of lenses, if you're in physics and you're working with refraction or reflection stuff, depending upon curves of these, it allows you to, lack of better terms, focus an image. This point here, the focus, is kind of like if you think about the focal point on a camera. What is it looking at? By moving the lens, it's opening and closing the parabola so that it's drawing the light in the image to be able to, keep using the same word, focus on a point. As you get into what this is allowing it to do, it's one of those things as for measuring sounds, measuring light rays, all that kind of stuff. Archimedes' mirror, if you want to burn a house down using a mirror, you have to be able to do this.
That was impossible.
I know it was very impossible on Mythbusters. Yes, sir.
We had the negative in, right? But it's like just the graph uses that.
Right, because you have to do the negative version of it as well. The calculator doesn't do plus minus automatically on a square root. So if you go to your second y, you know, like the next graph line down, if you type in on that y sub 2 here, if you type in negative square root of negative 6x, and now look at your graph, you'll get both curves.
The table for the first group.
Is it stopping at 0 and going error? That's right, because think about it. If you put a positive value for x in, you're taking the square root of 6 times the positive. Does that make sense? So if you're using the negative 2 times negative 6, you get 12, so the square root of 12 is something
Yeah, stupid.
Like the cicadas or something. That they come out like every 17 years. I went to camp 1 year.
Just meant to the positive.
Oh, because on the very last line, you have some capital letters. All right, yes, sir.
What is the point of this right? What is it here for?
It's a counterbalance. It's a counterbalance. You see, we're just talking about the curve today. I'll explain to you what this does later. It is just, think of it as a counterbalance. Lance, what do you got? Give me just a second.
With the directrix, we're not even using the directrix while we're finding it.
Not yet.
Oh.
Bailey? They're symmetrical. Parabolas. Oh, again, all I'm doing there on my calculator is that on the y equals, if I type in the, I'll put this in. I typed in volt in. I'm just going to put it in here so you can see this. What I did is I typed in the positive square root, and I took the negative square root. Because in order to solve for y, you have to take the square root. When you take the square root over an equal sign, it's plus minus. Yeah?
Could you just add the square root of 6x?
No. Because that means it's going the other direction. The square root of 6x will go this way. All right. Let's look at another one. Look at this one. Try another one. Same idea. Negative 12x is y squared. Negative 12x is y squared. So is this going to be opening left or opening right? It's going to opening left because it's a y squared. I know this is going to open left. I know that since y squared is already by itself, I can say that y squared equals 4px. Therefore, 4p has to equal negative 12.
Oh, you just
Because math. 4p has to equal the negative 12. Therefore, p is how much? Negative 3. Now again, my vertex is going to lie on the origin. My focus, since this is opening left, it's opening to the left, my focus is going to be at the ordered pair of, I'll just put this at f, negative 3, comma 0. And then the directrix, if the focus has the ordered pair of negative 3, comma 0, the directrix will be at x equals 3. And again, when I go to look at just some ordered pair to help myself figure out how wide or how narrow it's going to be opening, when I go to my calculator, you said at negative 3 it was 6? Okay. Did everybody, when you go to your table, did you use, print the negative? It was negative 12? That's why the first thing I do here, if I notice that it's a negative, I always draw a quick idea of which direction it's going to go, whether it's up, down, left, or right. That way I know what I'm doing when I go to my calculator to get an ordered pair. So I got an ordered pair at -3 and 6. So that means the symmetric twin is at -6. There we go. Okay. It's that straightforward. Okay. It's gonna be that straightforward. Let me show you the weird one then. Let's see, the weird one. Let's write the equation of standard form with a vertex at 0, 0, and a given directrix.
They're bad, but they add a dark.
Sure. Is y equals 2.
Y equals 4, so actually.
Whoa, 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 whoa. Get ahead of yourself. Right now, you know that you have a line at y equals 2. What kind of a line is y equals 2? A straight line, thank you. I was waiting for that
It's a
one.
directrix.
Is it horizontal or is it vertical? It's horizontal. Now, think about what this looks like then. When you get to this point where you're going to write equations out of what things are going to look like, my suggestion, well, the easiest way to do this, visualize it first.
So
Y equals 2. So that means I've got this horizontal line at y equals 2. The vertex is at 0, 0. So if the directrix is above the vertex, what direction is the parabola? It's opening downward. Everybody okay on that?
yeah.
That means my directrix, my parabola has to be opening downward. Now, from the vertex to the directrix is always equidistant from the vertex to the focus.
So
So if this is 2, this has to be 2.
E equals -2 times 4x.
So what do you put in the calculator?
I'm just counting. That's yeah, just showing that's equidistant. Nope. I'm just showing that these two values are equidistant. All I'm doing is showing that this much and this much are the same. That's all I'm doing there. They will always be equidistant to one another. So I know that my directrix is y equals opposite of p, and in this case, it equaled 2.
Wait, which one's P again? Like on the, okay, never mind.
Okay. What I've done there is that I've figured out that since it's a directrix that has a y in it, that means it's an x squared parabola. We've noticed that because it's opening downward. X squared parabolas either open up or down. And I know that since the since the line was y equals 2, that means that the directrix equation would be y equals -p. So what is the value of p? P is -2. Okay? Knowing that this is an x squared term now that because it's open downward, I know that x squared equals 4py. I just figured out what p was. 4 times -2 times y. Therefore, x squared equals -8y.
We did.
So you find it on calculator, you divide the y, and so you divide the.
You don't need to do that. All you have to do is write out the equation.
Well, I mean, just to get the points.
Yeah, you
Find
can
out
do-
the width.
You could, I mean, but in this case, we don't have to. All I have to do here in this case is just get the equation. Now, if you're right though, if you wanted to find the ordered pairs, yes, you'd have to divide out by the -8 and write it as -1/8 x squared equals y into your calculator.
Okay, why
And
would
that
it be
will work.
1/8? And so when you.
He's talking about if they had to go into the order, if they had to plot, if you had to graph that to get ordered pairs. You gotta get y by itself.
Okay, yeah.
Again, what we're looking at here is you're given a directrix, or you might be given a focus. those values, knowing that every single one of these vertices is going to lie at the origin, it's going to tell you what direction things are going. Let me show you another one like that. Yeah, we'll write another equation. Here I have a focus at 5-0.
5 over.
Watch out for the po-po. Sorry, this is bad. Again, I know that all of these are going to have a vertex at the origin. There's no shift involved here, guys. No shift. So the first thing I do, just put a little ordered pair out. Vertex is at the origin. If the focus is at 5-0, that means it's on the x-axis. Do you agree? It's opening to the right. So I know that it's got to be opening to the right. It's got to be going this direction. Okay? If it's opening to the right, is it an x squared or is it a y squared parabola? It's a y squared parabola. So I know right off the bat it's going to be a y squared equals a 4px. And p is 5. Why is p 5? Because the ordered pair is p 0. Remember, when you have this, your focus is at p comma 0, and we know we're at 5, 0. Therefore, p is 5. And then lastly, since I know that the ordered pair for the focus is p comma 0, if it's at 5 comma 0, p is 5. What's 4 times 5? Your answer is y squared equals 20x. And that's it.
Do you have to do the difference?
What's that?
Do you have to do the difference?
Nope, because all they asked you to do here is just write the equation. When you write the equation, it's usually a lot easier because you only need to have one of them. If you have the directrix, then you have to be careful with your signs. But if you don't, it's just it's that straightforward. All right. Remember, just draw a rough idea of what it looks like and go for that. Okay. Let me give you a few of these to try out for tonight. We'll go 17 through 77 every other odd.
What?
Oh, it's like 15 or 16.
That's a lot.
There's not that many graphs. There aren't that many graphs. There's only, I want to say, 5 graphs maybe total. The rest of them are all, what's the focus, what's the directrix, and then can you write the equation? Yeah, there's only, there might be 4 graphs. Okay. The rest of them are really identifying the focus, identifying the directrix, and then going from there. My suggestion, again, put this in your margin of your homework. This stuff, because now that it's correct. That way you can just cheat sheet off of that to do it. I mean, it should not be that long. Okay?